In this topic, we're going to be looking at waves. There's lots of different types of waves. So this diagram here shows a wave on a slinky. We can also have different type of wave on a slinky like this. You can have ripples on the surface of water. Then you can have sound. That's a really good example of waves. And also electromagnetic waves. So that includes light, radio waves, all the way up to X-rays and gamma rays. Okay, all these waves, they have something in common, which is that they all transfer energy from one place to another without actually transferring any matter. There are two types of waves that you need to know about. Let's look at the first type. So we've got a bunch of particles here and they're currently at rest. So that means there's no energy being transferred and there's no wave. I'm going to pull up one of the waves and disturb and introduce some energy to the system. And you can see the particles are now oscillating or vibrating up and down. Okay, so vibrations or oscillations is how we describe the motion of the particles. But what's actually going on is they're transferring energy from one to the other like this, and that's going to go all the way towards the right. So the energy is being transferred to the right. Okay, you can see the peak of the wave moving as well. So that's how you can tell the energy is going towards the right. But the particles are not moving, they're just oscillating on the spot. Okay, so this is a special type of wave called a transverse wave. And the oscillations in transverse waves are perpendicular or 90 degrees to the direction of the energy transfer. Okay, if you want to think transverse like transect, that's like 90 degrees. Okay, examples of these waves include waves on a string like the one I showed you a minute ago. So the particles on the slinky are just bobbing up and down and actually moving towards the right. Another example is ripples on the surface of water. So the water particles just going up and down perpendicular to the direction of energy transfer without moving from one place to another. Another example is S seismic waves. This is the type of earthquake. When an earthquake is produced, these waves transfer through the ground, and the particles here, you see they're going up and down while the energy is going towards the right. Or we say the particles oscillate perpendicular to the direction of energy transfer. Finally, all electromagnetic waves. So here, this diagram shows electromagnetic waves, which are made from electric fields and magnetic fields, which is why they're called electromagnetic waves. And the electric field and magnetic field oscillate 90 degrees to the direction of energy transfer. Okay, electromagnetic waves, this is, for example, light, radio waves, microwaves, all the way up to X-rays and gamma rays. Okay, we're going to look at the second type of waves now. So here we've got a bunch of particles initially at rest, so there's no energy being transferred. I'm going to go ahead and push one of these ends here, and the particles, you can see they're actually oscillating on the spot like this. Okay, so what they're actually doing is they're transferring the energy from one to the other. So the energy is being transferred to the right. And if you want, you can see the peak of the wave moving like this. So that wavefront is basically a line that joins all the peak of the waves. And you can see the energy is going towards the right. So this is a specific type of wave called a longitudinal wave, where the oscillations are parallel, or in other words, in the same direction to the direction of energy transfer. If you want to think longitudinal, it's the oscillations are along the same direction as the direction of energy transfer. So examples include wave on a slinky again, but here the slinky is being pushed back and forth as shown in the diagram, and the rings on the slinky are moving left and right in this example, and the energy is going towards the right. Okay, another example is sound. So the particles, when you make a sound, oscillate just like shown in the diagram above with the animation there. And they transfer the energy from one end to the other end. And then finally, P seismic wave, which is another type of wave that's produced during an earthquake, where the ground and the particles in the ground oscillate back and forth, left and right in this example, in the same direction the energy is being transferred.